Hello dear friends and welcome to the GeoCoast. Today on this beautiful sunny day I'm meeting Professor John Sweeney, who is a geographer and spent most of his life studying climate. Hello John.
Hello Maxime, how are you? Right.
And because we don't have a cameraman, I'm going to go behind the camera and film you talking.
Okay.
John, could you please introduce yourself and elaborate on what are the main areas of your scientific research?
Okay, well, I'm John Sweeney. I'm Emeritus Professor of Geography from Maynooth University. I've retired for about 4 years from the university, and over the past 40 years, I guess most of my work has been in the area of climate change, mainly in the area of impact analysis, climate modelling impact analysis, where we produce scenarios for the future for Ireland and assess where the key impacts are and how to tackle them.
John, and what was the origin of your interest in climatology?
Well, I always have been interested in climatology, and when I came to Ireland in 1978, I started looking at how rainfall is distributed across Ireland, and I started noticing that where places get more rain than other places is very dependent on the direction of the wind and the circulation of the atmosphere. And it began to occur to me, long before anyone was interested in climate change, that if the circulation frequencies changed, we would have quite dramatic changes in the rainfall we get in different parts of Ireland. And this led me on to start modelling the effects of, say, the depressions moving further north, or more in the way of summer anticyclones, and so it led me into providing some insight, I think, into what the future course of Irish climate will be over the years ahead as global climate change occurs.
And can you please elaborate on what type of methods are you employing in research when studying climate, and how these methods evolved since 1970s when you started your scientific career?
Well, I think in the early days, first of all, that you use the observations mainly from Met Éireann. I remember using 300 or 400 rainfall stations at one stage, and you mapped and you drew your maps manually, and you interpreted where the ISO lines would be from the data, and it was a very laborious process. And then, of course, later on, a lot of that became capable of being digitized and computerized, and we started using statistical models, first of all, tied to global climate models, and then later on regional climate models as computing power increased, and of course increased exponentially over the past few decades. And this has enabled us to be, first of all, more detailed in terms of spatial resolution for what will happen in particular parts of Ireland, although there is a lot of uncertainty still. But it also has enabled us to run models and mix them up and look at the weaknesses and strengths of models in a way that enables us to look at uncertainty and enables us to say, well, the models are in agreement here or the models are divergent here, and so we can maybe make a more confident statement in the former case, and we have to be more cautious in the latter case. And that kind of progress has continued to the present day. And it has enabled, I think, us to be more definitive in how we adapt to the future in terms of particular sectors of the Irish economy and also particular areas of Ireland where some crops may grow and some crops may not grow in the future, for example.
Mm-hmm. And in your research, as you said, you're using the data generated by meteorological services. Would this be the only data set, or would you have installed your own weather stations, performed your own observations?
Well, we did try to have a local weather station for a while, but of course it's a very demanding job to maintain and to run. So it is much more easy to use the standard meteorological observations. Now, when you look at those over time, you also have to be aware that things change around weather stations over 20, 30, 40 years. Trees grow, buildings appear, And so you have to look closely at the quality of that data, and we were involved in homogenizing that data to enable us to be more confident that it was an accurate portrayal of the trend in temperature and rainfall over time. But you know, you can't argue with thermometers, and you can't argue with very conscientiously made observations from the professional weather services, and that's what we've primarily used as a source of truth for our models, but also to enable us to see what's happening in terms of trends over the past few hundred years, because Ireland is quite a unique country in that it has one of the longest records of weather observations of any country in the world. In fact, we can construct, for example, rainfall trends now over 300 years in Ireland, and this shows a lot of things that we weren't aware of before, like the frequency of droughts, for example, was much greater than we thought before. But it enables us to put extreme events into a longer term context, and that's the value of using objective meteorological data, really.
And who was actually doing those measurements 300 years ago? And that's another question I wanted to ask, like when actually reliable records began. I thought it was mid 1800 something.
Yeah, well, yes, I mean, reliable records really were dependent on when the technology for good thermometers became available. And in fact, it was the quality of the glass that was important rather than the quality of the mercury that was in them or the alcohol that was in them. And in a lot of cases, these records started at the very end of the 18th century in Ireland, where we had places like Armagh Observatory, and then followed on by Dunsink Observatory, and later on Valencia and so on as well. A lot of them were in the big country houses where gentlemen of leisure, if you like, had a way of measuring with that early technology. We can also use records from things like documentary sources to calibrate, for example, the records that were kept by agricultural organisations, by people concerned with when they would harvest and when they would plant their crop. And they kept meticulous records, diaries, which we can use to compare with observations in the later stages and enable us to push back that record in an indirect way. Of course, you can use other longer term means of reconstructing climate, such as looking at bubbles in the ice core, such as looking at tree rings and so on. But really, we were more concerned with the changes in the past few centuries, because at the moment we're facing very rapid changes in the next few decades, and it's important for us to realise just how much they change by comparison to what our forefathers did in Ireland, maybe in pre-famine and famine times especially.
And in your opinion, John, what role has climate change got to play in changing coastal landscapes?
Well, climate change is something that will drastically change many coastal landscapes, because if you think about it, the coast is one of the most dynamic landscapes that we have, where the sort of irresistible force of the sea meets sometimes the sort of immovable force of hard rock. And in that area, maybe if you're thinking of places like the cliffs of Moher, climate change won't change the cliffs very much over time, because the rock is so hard it resists any form of erosion very effectively. But where you have soft coastlines, such as we have around us here, then even a slight change in sea level will shift the balance between deposition and erosion very much in favour of erosion. It will accelerate coastal erosion. And also, of course, we now expect storms to become more intense in the years ahead. We don't expect them to become more frequent necessarily, but the ones that do develop we expect to be bigger. There's a great heat source in the warmed up ocean out there, and that has to be released somewhere, and it's released in terms of wave action frequently on a soft coastline. So when you have, first of all, the changes in attack on the coastline, you make the coastline more prone to rapid retreat. And secondly, of course, if you're causing sea level to rise as we are with the changes in ice cover on land in places like Greenland and the alpine glaciers, then you're enabling those waves to attack from a higher platform. And that higher platform will attack areas that perhaps have been immune before to coastal attack. So, if you like, the coast is much more vulnerable as climate changes than it has been in the past. And where that coast is composed of, like around us here, of unconsolidated material, of sand effectively, then it's very rapid in terms of its removal under individual storms. What I think is interesting about the coast is it doesn't retreat gradually. We're not talking about something that, you know, goes back a few feet every year or a few inches every year. It retreats catastrophically under the effects of individual storms. So here in Wexford, if you get a storm from the southeast, this cliff may retreat much more in the course of 2 or 3 days than it would over the course of the rest of the year. So it means that it's a more risky environment in climate change terms. It means that we may have to abandon many parts of our coast which are vulnerable to coastal erosion. Is now a policy that has been adopted widely to counter changes at the coast that we expect to see over the next few decades. So basically, we can't be like King Canute and order the waves to go back. We have to simply accept that the sea will reclaim large parts of our landscape which are exposed and vulnerable, and we have to live with that and simply plan accordingly that our infrastructure, especially our critical infrastructure of roads, of railway lines, of power and energy supplies, are not compromised by the changes at the coast, and not. We have to be sensible where we put people and where we put those infrastructural assets, so that they're not damaged in the short term before they give a return on the capital that the taxpayer has invested in them. Okay.
And John, island is an island in itself, yeah? However, we have many small coastal islands representing perhaps most vulnerable environments in the context of the ongoing sea level change, as you said. In your opinion, what would be the main impacts of climate change on coastal islands, and what timeline are we looking at?
Well, Ireland's islands are generally located on the west coast, the really crenulated coast of the west, where there's lots of inlets and lots of bays and so on. And most of those islands are actually made of hard rock, so I don't worry too much about our west coast islands. There are obviously places in our inner estuaries like Bull Island and Dublin Bay, which are going to be very exposed and very vulnerable. But I don't honestly see a really big problem in the medium term for our west coast islands. I think we're looking maybe at a 1 metre rise in sea level for the next century. So I think in most cases the coastline of many of those west coast islands can stand up to that okay. I'm more concerned with the soft coasts that you get in the eastern half of the country. I'm more concerned with things like the Shannon Estuary, which has a lot of low-lying land close to sea level. And there are some places, admittedly, in the west coast where there are sandy estuaries. But for the most part, if you're thinking of Achill, if you're thinking of the Aran Islands, if you're thinking of islands off the Mayo coast, for the most part, they are hard rock and they will survive okay.
Well, myself, I'm a geologist, so I studied past climate changes over longer time periods, hundreds of thousands or even millions of years, by studying deep marine cores. And so from geological records, from ice cores as well, we know that climate has always been changing throughout the Earth's history. And this would be the argument of a lot of people who would say, what is this panic about, because climate has always been changing. So even before humans arrived to this planet, those changes were related to processes of astronomical or planetary scale, like solar activity, angle of Earth axis in relation to the sun. And the recent climate change that we are all talking about is it human-made, or is it part of the natural sequence of events that we have little control over?
Okay. Well, it's true to say that climate has always changed. It has changed through the geological history of the Earth. There have been times, if you go back several hundred millions of years, when even carbon dioxide was higher than it is at present. There were times when the Earth was much warmer and indeed much colder than it is at present. And these have been driven by various internal and external forces acting on the planet. The most recent drastic change, I suppose, has been the succession of Pleistocene glaciers that traversed the planet, or part of the planet, and then retreated, came back again. And we now know that those are driven essentially by long-term changes in the Earth's orbit around the Sun, in terms of the attraction of the big planets of Jupiter and Saturn, which disrupt the Earth's orbit a little, and change the distribution of radiation on the Earth over very long time periods. And we're talking here about time periods of 100,000 years or maybe 25,000 years. And these have been the pacemakers of the Ice Age, as we now know. But in terms of where we are today, we're now seeing a very rapid change in warming on a time scale which we haven't really experienced during human occupants of the planet. Many of these astronomically driven changes of the long-term past occurred when really there certainly weren't 5 billion people on the planet. There might have been only a few million people in some cases, and in the earlier times none at all. So we can't simply go back to those kinds of events and say it's a natural phenomena. And the reason for that is that we can now use our computerized models to more or less prove what's causing the current set of changes to occur, because given the great advances we've made now in computing power, we can run climate models which we can replicate recent past temperature changes in very accurately. We can run them, for example, with a pre-industrial level of carbon dioxide in them. We can then see to what extent does our model replicate the changes of the past century or so. And when we do that with a pre-industrial level of carbon dioxide, it doesn't agree at all with what's been happening to global climate in the past few decades. It's only when we put in the current values of CO2 into our models that we find our models then replicate almost perfectly what's been happening with the Earth's temperature. And this is kind of a corroboration of the fact that for the first time in human occupants of the Earth, it's us that's controlling climate. It's anthropogenic influences that are determining which way our temperature trend is going. And for the first time in human occupants of the planet, therefore, climate is a prisoner of people. Unlike those people that went before us who were very much prisoners of climate in terms of a harvest, in terms of saving enough of their crop to tide them over the winter. They were dependent completely on the vicissitudes of climate, whereas today really we have to recognize that now climate is dependent on us for its future course, at least in the next century or two. And that's why it's so imperative for us to play our part in ensuring that over the next few decades we don't rule out the sort of the possibility of having a more benign future for those that come after us in terms of tackling what we now know to be the causes of climate change, which are undisputably now recognized as anthropogenic.
And when investigating contemporary climate changes, do scientists take into account non-human contributing factors such as volcanic eruptions, solar activity? And if yes, what is the methodology for delineating between these factors and the human-made contributions in the graphs that are being produced? You probably partly answered this already. It's through computer modeling.
Okay,
Is there anything to add?
Well, computer modeling has advanced considerably now. So, I mean, it can accommodate natural things such as volcanic eruptions. It can also have a reasonable stab at including things like the El Nino oscillation of the southern oceans. There are weaknesses still in modelling, especially in how it handles cloud and cloud feedbacks, and especially also in how it handles ice and ice albedo feedback. But the bottom line is that our models have become much more reliable and much more capable of simulating the recent course of climate. Now, of course, we have to remember they're models and things can go wrong, and we have to be prepared for uncertainty, which will always exist with model output. No one can see the future perfectly. But I think we have to place a lot of confidence in the way in which models now convince us and confirm the anthropogenic role in climate by, of course, modelling without CO2, modelling with CO2. And as well as giving us that signal for the role of people, we can model several hundred times now for each category, and we can also say how often would a particular extreme event occur naturally, and how often would a particular extreme event occur with extra CO2 and greenhouse gases in the atmosphere. And this enables us to attribute extreme events and to say with increasing confidence that the probability of a hurricane like Ophelia arriving on our shores is magnified by a certain factor as opposed to what it would have been in the absence of greenhouse gases in the atmosphere. And that, of course, is a very powerful weapon to use for policymakers and decision makers to convince them that those hazards will have to be managed more effectively in the future.
And would it be right to say that past rises in CO2 before humans arrived to this part of the universe were linked mainly to volcanic eruptions?
I think so. I'm not 100% sure, but I think they were. You probably know more about that than me.
I mean, what I know, like there's thousands of volcanoes even in the mid-oceanic ridges.
Yeah, they would release lots.
And like there's thousands of eruptions each year.
Yeah.
Do we have any instrument through geophysics or whatever to actually estimate the annual contribution of volcanic activity towards greenhouse gases? Is there any methodology to do that, to subtract it to human-made?
Yeah, well, we have no instruments other than just looking at the carbonate content in the rocks, I think, in that case, and seeing that, this was a carbonate-rich environment. But I don't know.
But I mean now, for example, in 2019, probably there were some eruptions which were not on land, but in the sea, and which are not obvious to people. Yeah. Is there some methods, are geophysicists measuring those eruptions? Are they monitored? Do we know about them? Can we estimate the contribution of CO2 or other gases from those eruptions or no?
Okay, well, monitoring an undersea volcanic eruption is both dangerous and not very easily done. What we can look at is the acidity content of the ocean, and we can see the way in which the pH changes. And that's been a problem that we've become increasingly conscious of, because many forms of marine life are very delicately balanced to the pH of the ocean, which is becoming more acidic, because about 80%, maybe more, of the heat that we have trapped from the greenhouse effect is going into the ocean. The atmosphere is only absorbing a tiny amount of it at the moment. And so the ocean have saved us, if you like, from many of the problems we would otherwise face due to the amount of carbon we're putting into the atmosphere. There are risks associated with the warming of the ocean and the release of greenhouse gases, especially in the form of methane clathrates down the road, where there is methane trapped in the cold ocean at great depth, which as the ocean warms up, and it's more long-term than the next few decades, but as the ocean warms up, there is a risk of those methane deposits being added to the atmosphere and accentuating the problem very considerably indeed. But I don't honestly know about the geology of
That's okay.
the CO2, I'm afraid.
No, I was more curious if contemporary climate research takes this into account somehow. Is there some methodology to take this into account?
I don't think
because
there is.
Otherwise, for example, if this year, assuming we have 2,000 eruptions that are not obvious to us, but we can be saying, oh, there's so much CO2, but in fact they were produced by volcanoes, not by factories.
Yeah. Well, I mean, we do measure the atmospheric emissions, and we can model the effect these have had in the past on temperature. You know, the eruptions of things like Krakatoa, we know, will cause a diminution in global temperature of about 0.5 degree for the next 6 months to a year. And we know that, you know, in the past we've had clusters of erosion, clusters of eruptions, which may have contributed to some of the noise in the marine isotope record, for example. But I don't think we monitor the undersea eruptions, in all honesty.
And if there is an undersea eruption, would these greenhouse gases emitted through the volcanic eruption be absorbed by the ocean, or would they get into the atmosphere the same year?
Yeah, it would. Most of it would be absorbed by the ocean. The CO2 is a soluble gas, so it will be absorbed and make the ocean more acidic. The amount bubbling up to the surface, I haven't seen any science in terms of looking at the emissions reaching the surface from those. I don't think, my feeling is it's not a significant contributor to global greenhouse gases at the moment. But of course that could change if we had a series of eruptions along plate tectonic boundaries, for example.
And for somebody who is absolutely not familiar with the subject, can you please explain what are we talking about when we refer to the term greenhouse gases?
When we refer to the term,
what is greenhouse gases? What are we talking about?
Well, I mean, our atmosphere is composed mostly of nitrogen, about 80%, and the remainder is mostly oxygen and some trace gases. And the importance of what remains in tiny amounts, such as carbon dioxide, which exists in concentrations of about 410 parts per million, and methane, which only exists in parts per billion, about 2,100 parts per billion. The importance of those gases is that they can act to stop heat escaping from the surface. They allow the sun to radiate into the surface and to heat up the surface, but then as that heat tries to escape, it's trapped in those gases, which are very effective in absorbing it. And it's rather like a greenhouse, where the sun comes in and warms up the plants and it retains the heat within the greenhouse. It's not a particularly good analogy, I have to say, but it's the nearest one we have. And that's why they're called greenhouse gases. And they consist of carbon dioxide, which accounts for about 80%, about 70% of the warming that we've achieved so far in the past century or so, and methane, which would account for about 30% or so. There are other trace gases which are less important. Some of them are manufactured by us, such as sulfur hexafluoride, which is a very potent greenhouse gas, but they exist in very, very small concentrations, and the main culprits are therefore what we call the greenhouse gas family, are mainly composed of carbon dioxide and methane.
And what do you think about statements claiming that most greenhouse gases are represented by water vapor? Is it true or false?
It's true. Water vapor is a greenhouse gas as well. It exists perhaps as a more effective absorber than many other greenhouse gases, but it's not changing significantly over time in the way in which these other human-induced greenhouse gases are. So we can't ascribe the changes in temperature that we've seen to changes in water vapor concentration, and we have to look elsewhere for it. But water vapor has always been there. It's been there in a relatively constant amount, and it is a potent absorber of outgoing heat, yes, but it's not the cause of the warming that we've been seeing.
And in your opinion, John, what are the links between air pollution and climate change? For example, we know that too much aerosols in the atmosphere, like after volcanic eruption, can actually result in the cooling of the climate because it doesn't let the sun energy to reach the surface of land. So what's your opinion on how the amount of aerosols would actually affect climate change?
Well, aerosols are one of the great mysteries which haven't yet been solved in terms of how to handle them in global climate models. Because a lot depends on the altitude at which they occur. But in general, aerosols cool the Earth's climate. And we know after a volcanic eruption that the Earth's climate will cool by 0.5 degree or so if that eruption takes place in an explosive manner close to the equator. Aerosols, well, we've been responsible for causing them in the past. We are beginning to get a handle on them, I think, in terms of reducing the sulfur content of many of the fuels that we've been using. But local air pollution down at the surface is not really a big player in the global climate change situation. I mean, aerosols, yeah, they are a problem for bringing into global climate models at the moment, but I think it's important to emphasize that aerosols at the surface of the Earth in the form of smoke and particulate pollution, they don't really play a big part globally in terms of climate change. What does have an impact is surface-based ozone, which has a complex relationship to warming. We think of stratospheric ozone as a problem in terms of ultraviolet rays coming in, but it's really a different beast, if you like, from surface ozone, which we produce mainly at the surface, and that can accentuate warming around industrial areas, but also even around large areas in rural parts as well. So we do have to control that kind of pollution as well.
Would you think that the main reason behind increasing amounts of CO2 in the atmosphere is global deforestation of this planet that was ongoing for thousands of years since people started reclaiming land for agriculture? And if yes, then would planting trees solve at least partly this problem of climate change?
Well, I mean, global deforestation has been occurring, and in a place like Ireland, for example, we've largely deforested the island over the years. What's happening in more recent years, however, has been the scale of deforestation has been enhanced by technology. So whereas in the past it was limited by what people could do with an axe or a small tractor or something, today it's much larger, especially in the rainforest, which is so important for providing oxygen for the planet as well. I think planting trees will certainly help by means of providing more photosynthesis and providing more oxygen and taking carbon dioxide out of the atmosphere. I think deforestation at the moment contributes maybe around 1/5 of our carbon dioxide change in the atmosphere. And of course we make matters worse not by simply removing the tree, but frequently by burning the tree as well. So in addition to removing the source of sequestration, we're adding emissions to the atmosphere from burning on a grand scale. So I think, yes, I mean, there are many schemes around the world to increase afforestation, especially at the moment in the Sahel in Africa, where there's a huge attempt to provide what's called a green wall. And that's also to enable the soil to be stabilised and to fight drought and desertification as much as to sequester more CO2 from the atmosphere. But trees are an important ally for us in the years ahead, and we should encourage reforestation of areas that have been deforested, and we should protect as much as possible the global community good which we have in the tropical rainforests, in particular in Brazil and in the Congo basin, where really, you know, to remove the trees there would be pretty catastrophic for our efforts to fight climate change in the future.
Mm-hmm. And for instance, in simple terms, if you and me were using trees that we plant in our garden for heating our houses and then replanting them, can we say that we are carbon neutral?
There is a controversy about biofuels at the moment. Certainly, if it's the view of the European Commission that if you are using trees sustainably and replacing them on a regular basis, then you're not adding to the burden in the atmosphere, because the trees you replace them with are sequestering again the carbon dioxide you emit when you burn the first generation. I think we can overemphasize the role these play. It does, for example, make no sense to bring trees from distant locations to burn in our power stations. But on the small scale you describe of having maybe trees in your garden which are subsequently renewed, or a small plantation which is subsequently renewed, it's a better way of going than burning diesel and petrol. That would be but it's not the complete answer. I think we have to move to a more renewable form of energy, even beyond burning anything, and renewable forms in the form of solar and the form of wind energy provide the best way of being sustainable in the future, and we can leave the trees to grow in that situation.
Well, I think it's good to talk about renewable energy in rich parts of the world.
Okay.
But like if we look into Asia, Africa, like if people just don't even have running water or the toilet, if you start talking to them about renewable energy, they're just gonna look very surprised at you, like, yeah? So it's a big challenge to persuade it on a worldwide scale, don't you think so?
Yeah. There's been a revolution in renewable energy, especially in the form of solar energy, where the cost of providing solar panels has fallen by around 90% in the past decade or so. And this is opening up opportunities for places in Asia, in Africa, to go that route. Now, of course, we have to provide funds to enable them to do that from the developed world, because after all, we are the people who created the problem. And if we don't want those countries to go down the same route, make the same mistakes that we did, we have to provide the finance for them to make a sustainable future. And that would include, for example, providing them with the basics of everyday living. You can't tell a person in Africa to put a solar panel on their roof if they haven't got running water or they haven't got access to toilets and things like that. So we have to look at the responsibility of the developed world to aid development in those kind of situations, and to make it easier for people in Africa and Asia to avoid the mistakes. I mean, we've seen, for example, the way in which mobile phones have effectively transformed parts of Africa and Asia, where they've skipped having the landline system that we became so tied to in the past few decades. And we have to do the same now with fuel sources, and we have to enable them to see a way ahead which is economically feasible for them, and not to deny them the development opportunities. Let's remember their greenhouse gas emissions are probably a tenth or less than us here. So we have to allow them a modicum of development to enable them to get airborne, if you like, and then give them the direction and the support they need to be sustainable thereafter. And there are signs that's working already in many developing countries. In China, for example, there's a huge increase in renewable energy going on at the moment. They have seen, I think, the wisdom of doing that. And I think that will be something that we will see spreading very quickly in other developing countries in the years ahead.
Oh yeah, John, in your opinion, what would be more correct term to use, global climate change or global warming?
Well, we used to traditionally talk about global warming, but in a way that's a misnomer, because it's not warming which is the key variable in many parts of the world. For many parts of the tropics, for example, it's changes in rainfall. For even places like Ireland, where a degree or two won't make an awful big difference, but changes in rainfall would. So I think the expression global climate change is a much more accurate expression, which encompasses the real impacts better of what we expect to occur.
And John, I know that you were president of Antashka, the National Trust of Ireland, and currently you're still involved with this organization as a director. So what was and what is your role in this organization? What it's all about? Can you explain?
Well, Antashka is the National Trust for Ireland, and it's the body which seeks to look after, I suppose, the heritage of Ireland, both in terms of its built heritage and its natural heritage. It's a non-governmental organisation which receives no funds from the government, and I suppose it has two main strands to it. The first is the education aspect, and it's very much involved in environmental education, and people may be familiar with things like blue flags or green schools or clean coasts, which are administered by Antashka as part of the European body. But also it has an advocacy role. It's an organisation which has special status in terms of planning applications which may affect sensitive areas, have to be referred to that body, and they then will consider making a submission on the basis of that. So it is an active organisation which punches well above its weight, considering it has a very limited number of employees, and its main objective, I think the word Tashka means treasure. Its main objective is to look after what we think of as the treasures of Ireland environmentally. They may be heritage buildings, they may be heritage landscapes, they may be threatened landscapes, and that's where the main focus of the organisation would be.
Mm-hmm. And John, I know that you have done some research evaluating the impacts of potential climate change on various aspects of coastal agriculture in Ireland. So what's your take on this?
Coastal agriculture in particular, many of Ireland's coasts, on the east at least, are composed of light sandy soils. And those soils warm up quickly in spring, and they can cool down quickly in winter as well. But the main impact, I think, of climate change on the soils of Eastern Ireland are likely to be in terms of drier summers, where a lot of our potato crop, for example, is grown on sandy soils around the Dublin area. And potatoes simply don't like dry summers. They need moisture to swell up the tuber. And so they're a crop that will not do particularly well as climate changes without some form of irrigation, for example. There are other crops we grow close to the east coast which will do quite well, such as maize. We will continue to have good yields from wheat and barley. But we could perhaps use a bit more in the way of root crops and horticulture. We, of course, are an island that's covered in grass, and grass will also suffer during dry summers, as we've seen during the drought a few years ago, when yields of milk went down, when grass stopped growing for cattle to eat, and they had to be fed indoors in the middle of summer, which you would not have considered a likelihood in years gone by in Ireland. But the coast itself, well, it depends which coast you're on. The problem may well be in biodiversity rather than in agricultural crops at the coast, because we have a biodiversity crisis as well as a climate crisis. And some of our amphibians, for example, are going to be problematical in the future. Some of our bird species are going to be problematical. We wonder about our seabirds and how they will cope with a warmer ocean where the food supply may be changed, where fish stocks may be different, and so on as well.
And do you have anything else to add, talking about the specifics of coastal agriculture? For example, like, in my opinion, like, coastal farmers, they face certain challenges with winds from the ocean, with salt spray, with coastal erosion, seabirds eating the crops. And do you have any opinion on the specifics of the coastal agriculture in general? Have you studied this?
No, I don't think anyone studied it. The only issue for coastal farming is coastal erosion, and perhaps drier soils. But nobody studied it, as far as I know. I mean, it's not an area.
So it's not a huge effect of saltwater spray on the crops?
No, nobody's too worried about that. Certainly not on the east coast. Maybe on the west coast you might get more, and we know that saltwater spray has penetrated far inland during some storms historically, but it's not considered a major difficulty.
I just seen cars of people who live near the sea, and they get rotten much faster.
But that's the least of our problems.
And you have been a member of the Intergovernmental Panel on Climate Change, is that right?
Well, it's not an organisation that has membership.
But I know that you contributed to the report, which won a Nobel Prize, and Could you please elaborate? What was that work
Yeah,
about?
the Intergovernmental Panel on Climate Change is the authoritative body on climate. It reports about every 7 years, and it's, as its name suggested, is composed of members of government and also scientists. And the scientists do the work in terms of preparing reports on the state of climate. They don't do any research. They synthesize the research that has been done up to a certain date and really say what is the state of play in this area. And this has been happening since about 1990, when the first assessment report was produced. I was involved in the fourth assessment report in 2007. I contributed to the chapter in Europe, and I was a review editor on the chapter in agriculture. But we're now facing up to the sixth assessment report, which is due in the next couple of years. And that will be a landmark report to guide policymakers as they grapple with the Paris Agreement, for example, but also to tell us what have recent developments in the science told us about the course we're on and the extent to which we have time to change direction or not.
And I know that you have been involved in science for over 40 years. You said you arrived to Ireland in 1978, so which is like 41 years ago. And short questions with the short answer.
Right.
You mentioned previously that when you started studying climatology, there was the topic of climate change. It wasn't fashionable, let's put it this way. Yeah? So do you remember the year when global climate change or global warming became part of the international agenda and became like a keyword in all funding calls?
Yes, I mean, climate change was something which, if you were in a weather service in the 1960s or 70s, to be told you were the climatologist was not considered a very lucrative and attractive job. It was considered more an archival job. I guess that applied really up until the early 1980s. I think there were times when Professor Hansen, for example, in the United States, made his key submission to Congress. I think that must have been in the middle 80s. I'm not sure exactly when, maybe a bit later. But there was no seminal moment when the people suddenly got aware of the issue. What has been happening is the scientists have been telling the story for a long time. The public have only recently grasped the message. And in a way, that's a failure of science as much as anything else, and a failure of science communication, because it comes as no surprise to many scientists what's happening today. They've been warning about it for about 20 years now, but it does come as a surprise to the public that we are facing such acute problems down the road. So we're talking about that, right? I didn't give you a date. So
basically mid-80s, yeah?
Yeah,
that's
mid-80s,
when
I think.
The topic became popular.
Jim Hansen's stuff would probably be considered seminal, and I suppose the third and this was before the first IPCC report. And the scientists were establishing little groups in the mid-80s to try and establish whether climate change was natural or anthropogenic. I guess, many scientists even then knew it was anthropogenic, but I suppose it was really, maybe I should have said the first IPCC report in 1990 was a key.
So that's when the fashion started?
Yeah, I think that's when, I know that there were scientists closeted in little rooms and hotel rooms in the 1980s and asked by the International Council for Science to report on whether climate change was a reality and we should be concerned about it. And it was their report which led to the setting up of the IPCC. I think there was also the Rio meeting of, was it 1992 or something like that?
Early 90s, I don't remember.
I think it was the 90s, where the United Nations Framework Convention on Climate Change was set up and signed by the countries attending that Rio meeting. That would be a seminal point. Gro Harlem Brundtland had been talking about sustainable development up to that point, but it was after the Rio conference that things began to really fall into place quickly. I don't know the date for that.
Yeah, that doesn't matter.
It could be 92 or so, but I'm not sure.
And taking into account all scientific research and what you told us today, and assuming that the human-triggered climate change is happening, in your opinion, can it be stopped, or are we at the stage when we're only talking about adaptation to consequences?
Well, the IPCC 1.5 degree report, which came out in the autumn, had some bad news for us in the sense that we were already 1 degree warmer than we have been since pre-industrial times, and that it was going to be very difficult for us to avoid warming to 1.5 degrees. And that's a critical threshold, for example, for the small island states of the Indian Ocean and of the Pacific. What the IPCC said was, yes, we can avoid it, but we need to undertake radical reductions in our emissions. And we need to have a 45% reduction in emissions by about 2040. And for the developed world, we need to ensure that they are almost all decarbonised by the middle of the century or shortly thereafter. That's a very big task for us to undertake, and at the moment the political will is not there in some cases. But I think we have to be hopeful. We have to have hope that we will see the light and we will change our ways, because we cannot give people a completely pessimistic outlook and force them to throw their hands up in the air in despair. This is a problem which will require the whole society, global society, to embrace and to tackle if we're to have any chance of avoiding 2 degrees. Our chances of avoiding 1.5 degree is pretty slim in my opinion at this stage, but we have to avoid the even more dangerous threshold of 2 degrees at all costs.
John, the famous UK conspiracy theorist David Icke claims that climate change is part of a political agenda originally developed by the Club of Rome, which was set up in 1968, that aimed to use the environment to transform society and centralize power, as he claims that in order to save the planet from global warming, we need to have centrally controlled approach to it. So, in other words, to set up a worldwide dictatorship. What's your opinion on this? Has the climate change got any political agenda, you think?
Well, scientists are not noted for having a political agenda. In fact, it's very difficult to persuade scientists to say anything about policy in public, and that's been one of our communication difficulties over the past few decades. But at the end of the day, we're arguing with thermometers. There's no doubt that climate is changing, and it's changing rapidly. Our millions of thermometers are telling us that. Our climate models are telling us that. So I think we have to divorce all of these, the political mumbo-jumbo from that, and just the reality is that we face a crisis, and the crisis is a crisis of our own doing, and a crisis which will only be solved by ourselves. I don't subscribe to the conspiracy theories. It's very easy to gain publicity from being sensational about such theories, but in this instance, the reality is the evidence on the ground, the evidence of changing ice sheets, the evidence of our thermometers changing, our biodiversity changing. There's just no way of getting around the fact that science is telling us a very clear signal that climate is changing, it's our fault, and we have to do something about it quickly. And that's where I think we should end this argument in a sense, because diversions into conspiracy theory are just nonsense in my view.
So you think claims that originally this topic was kind of imposed on the scientific community is false statement?
It's completely false. The scientific community...
So it was bottom-up approach rather than the other way
Yeah,
around.
The scientific community is globally doesn't fall for that kind of thing. So I think we can dismiss it. 2 planes now. There's one here as well.
Taking flying lessons probably, huh?
Yeah. good day for aerial photography as well.
We've already done it. Yeah. And another question, it's not a conspiracy theory as such, but actually what I'm going to say now, it doesn't contradict much what you already mentioned before, but probably to a different extent. So a few days ago I was watching an interview by UK meteorologist Piers Corbyn, brother of Jeremy. Have you ever heard of him?
Yeah.
So he claims that carbon dioxide levels follow the temperature. For instance, he says that after the last ice age, an Antarctic temperature went up, and about 800 years later, the amount of carbon dioxide in the world went up. So, in his opinion, the reason for the extra CO2 in the atmosphere that we see now is the delayed effect from the medieval warm period, when the extra CO2 emitted from the upper layer of the oceans was absorbed by deeper cold waters, which came out to the surface only now to emit the CO2. So it kind of overlaps with what you said before, that CO2 can be sunk in cold waters.
It is true that at the end of the ice age, the warming up of temperature and the increase in carbon dioxide were not in phase. This is an argument that's often used by skeptics. It's one which has run out of road in many ways, and it can be easily demonstrated if you shake a bottle of fizzy drink and take the top off. You'll see the carbon dioxide release. Or if you warm up a bottle of fizzy drink in a radiator and take the cap off, what it tells us is that warmer ocean can hold less in the way of CO2 than a colder ocean. So it degasses the CO2 to the atmosphere. So the ocean warms first, and then the CO2 follows a few hundred years later. And thereafter, then the feedback effect between the extra CO2 and temperature kicks in. But the initial phase of the operation is simply the degassing of the oceans, and it happens at the end of a warm period as well. So it's a spurious argument which has now largely been, it's been certainly destroyed scientifically.
So basically claiming that CO2 emitting now from the ocean in the atmosphere is the CO2 from 800 years ago has no grounds?
No, we may have CO2 in the atmosphere which was emitted a few centuries ago, either from the ocean or from the land, because of the residence time of CO2 in the atmosphere. But the main body of what we're putting into the atmosphere today is what's warming up the Earth, because we're increasing that concentration over and above natural levels. So we've had slight changes over time, but they've never in the past 800,000 years exceeded the pre-industrial level of 280 parts per million. It's only today we're up at 400 parts per million. The medieval warm period, if it existed, and I don't think it was a global event, but in any event, we've had warm periods and interglacials in the past, which are not too much colder than the present day, and in those circumstances there was no increase in CO2 above the pre-industrial level.
And could we say that ultimately the outcomes of climate change with increased storminess and higher wind speeds, for example, would be in a way good for renewable energy generation?
Well, wind turbines have two cut-off points. One is when it gets very calm, like it is today, and the turbines don't turn. The other is when the winds become too strong and there's a risk of the whole thing catching fire or breaking down. Increased wind energy will be beneficial for wind farms and for wind turbines in general. Given that we expect storms to be slightly less frequent, but the more intense ones to be, the bigger ones to be more intense, I don't think that we can expect a major change in wind energy potential as climate changes, certainly in Ireland at least. So I don't think it's a major factor. It may actually, if we have slightly less frequent storms, we may get more even wind speeds, and it may be beneficial for generating wind energy in that situation.
And finally, John, taking into account your over 40 years experience of studying climate, in your opinion, what should be the main steps now? What should people actually do? Is there a list of things that you think are imperative to actually make the situation better?
Locally or nationally or internationally?
Can you review both? Like,
right,
for example, on the scale of Ireland, and that's another question altogether, because like I'm not convinced at all that changing anything on the scale of Ireland has a global impact. Because we're so small.
Yeah.
But yeah, just share your views. Like.
Well, I think in terms of taking action, we have a responsibility in Ireland here to play our part internationally in the first instance. We emit more greenhouse gases than the 400 million poorest people on the planet. So we have a responsibility to them. We also have a responsibility to show that we are acting in a way in support of other international efforts by even larger countries. So there's no excuse for saying because we're small we shouldn't bother. Domestically, of course, there are other forces at work. And domestically, at a personal level, we should also try and minimise our own carbon footprint. The best way of doing that at the moment is by reducing our energy demands for heating, by retrofitting our houses and having more energy efficient systems that heat our house. We also need to look at our energy demands for transport, and this entails us doing the kind of less dependency on cars than we perhaps have been used to in the past. So we should be trying to walk a little more, trying to drive a little less, trying to fly a lot less if we can. And also in terms of our land use, our agricultural systems, I think we have to look at the extent to which we need to have large systems devoted to meat production. In Ireland, we do need to have systems devoted to meat production, but we don't need to be constantly increasing the intensity of that as a result, increasing our greenhouse gas emissions. And then that's a bottom-up approach. A top-down approach coming domestically is that we need leadership from government, we need plans, and we need to have policies in position which will enable individuals to adjust to climate change more readily, to enable them to take those personal decisions that we all need to take to tackle this problem. So it's a case of squeezing from above, squeezing from below, and also playing our part internationally. And if we do all that right, then we'll have warmer homes, we'll have more sustainable environments, we'll be better fed, and we'll have a prospect for our children and grandchildren to enjoy a more sustainable future than they otherwise would at present.
And globally, what should the population
globally,
plan to
of
do
course,
globally?
We are committed to international agreements such as the Paris Agreement, and globally we have to make a pledge every 5 years under that agreement to make certain reductions in our greenhouse gas emissions. Now, every 5 years that pledge has to be stricter than it was 5 years earlier, and so that ratchet over time will, if you like, provide an inducement, a stimulus to our policy makers to take the steps necessary to comply with our obligations. In Europe, we in Ireland also have European obligations, both for 2020 and 2030. We're going to fail the 2020 ones miserably because we haven't done the necessary actions over the past 10 years. We're also in danger already of failing the 2031. So we need an action plan for climate, which is not simply aspirational, but which forces people to make the necessary changes in lifestyle, changes in energy systems, which sends a signal also to the market and also to the energy suppliers, to the transport suppliers, that enables them to respond to changed demand and to respond to the express wishes, both of our elected officials, but also of the general public at large.
But does it actually make sense, for example, for people in such small countries as Ireland, changing the day-to-day living standards and habits in the context of globally such big countries like United States unsubscribing from humans?
Yeah.
Does it make sense? Because it's like we're talking about completely different scale of contribution of bad things from United States and Ireland, for example.
Yes, I mean, Ireland is a very small contributor in the global scheme of things, and you can throw your hands up and point fingers at other countries. You can point fingers at Russia, you can point fingers at Saudi Arabia, or you can point fingers at the United States these days and say, what does my little contribution matter in the wider scheme of things? And it's rather like an individual walking down the main street of a town and saying, well, if I throw my bus ticket here, it doesn't matter. But if you accumulate all those bus tickets, if you accumulate the costs of solving the litter problem, then you realise that everybody has to play their part, or else the whole system breaks down. So the leaders of those big countries may not always be there. There may be changes that happen where they adopt a more benign and enlightened attitude to climate change in the years ahead, and we have to await that. But in the meantime, we can't get down the slippery slope ourselves and say we're not going to bother trying, because that is defeatism and that is selling short the next generation, which is something that we really can't do.
Is there anything else to add about this coastline, and you've done it in the very beginning?
Yeah, I did it in the beginning. I mean, these are the terminal moraines of the last glaciation you're looking at here, and it's all the way down the coast, and there are offshore sea bars that mark standstill stages as well. But this is where, I suppose, the last ice age kind of stopped coming in from the Irish Sea. So it's left behind a legacy of very sandy soils along here, which is great for people in the springtime to grow early crops and fruit and early flowers and so on, and it drains very well. But you know, it's more the vulnerability of the coast, which I think I talked about at the beginning, really.
Okay, thanks very much, John.
You're welcome.